Hello, my name is Silviu-Tudor Serban. I'm an Intel software innovator and the founder of Helios Vision, which is a computer vision startup. And I'm going to talk to you about key ingredients for crafting intelligent robots. So, how would one define an intelligent robot? Well, a simple definition would be that a robot is able to take actions, make choices based on input from internal and external stimuli. All right, so let's see a few robots that do that. Let's call them intelligent robots. So for business and entertainment, we have Pepper and Lynx. They're both used in business cases, and Lynx more for entertainment. Now, for the smart home, we have robots that have a quite more cute look, smaller and child-friendly. They do have a lot of use for taking care of the house and monitoring the kids, and also most of them have Alexa-like features that allow us to order something online or just talk to the robot. Now, for assistance and service, we have Yumi. Yumi is used usually for elder care. And we have Furo, which is a service bot. I think it's already available in many places. I saw it in an airport not a long time ago. So, what is the essential element of an intelligent robot? Well, the answer is simple. It's software. And to be more specific, it's artificial intelligence. By that we mean speaking, seeing, and understanding. So let's go into the, let's say, first important topic, which is conversation. We'd like to be able to speak naturally to the robot. So for that, we need the speech-to-text systems that are accurate and understand perfectly what we are saying. More than that, we want our robots to be able to talk back to us and do that dynamically. Not just like a GPS pre-recorded voice. So we have a diagram for language understanding. We have the speech, which goes into the natural language understanding engine, where hopefully the intent of the sentence will be recognized and would lead to a fulfillment done by the robot. So what we call things that we train the robot to do, and the robot can then repeat and do perfectly, it's called skills. This is a name that was chosen by Amazon and I think Microsoft alike for teaching their bots new things to do. So okay, so how to make a robot conversation ready? Well, I was speaking before about Alexa, Microsoft Cognitive Services, or IBM Watson. These are among the top cloud service APIs for building conversations into your applications or in your robot, if you prefer that. Now, another way to build in conversation into your robot is to train your own AI. You can do this through machine learning or deep learning, and one of the best frameworks are TensorFlow, Caffe, Theano, or Nirvana. These are really user-friendly or developer-friendly. You don't need to be a researcher or a PhD to use them for training your own networks, and the results obtained with these frameworks are really, really promising. Now, the second most important thing is vision and understanding the surrounding environment and let's say detecting objects, tracking people or animals, let's say moving cat or a dog, and recognizing what are the objects in front of the robot. More than that, the robot will interact with people. So it'll be important if the robot can identify and more than that, understand emotion, and other characteristics of humans. Now, getting from point A to point B. Well, for navigation, we have SLAM. SLAM is an acronym for simultaneous localization and mapping. It allows for real-time navigation and environment mapping. Okay, so in regards to SLAM, one of the cool things I would like to show you, it's ROS, comes from Robot OS, and it's actually a platform we're using for our robot. It has built-in SLAM features, and I highly recommend it to anyone starting to build a robot and trying to add computer vision features to it. Now, we're going to talk about Astro. Astro is a robot that we're developing. Let me show you. So Astro is an intelligent robot. Its purpose is to improve productivity and safety in the workplace. And we're trying to do this in multiple ways, where we've developed a virtual assistant that can naturally talk to its colleagues and perform tasks based on the trained skills. More than that, Astro allows teleconferencing between a remote user and his colleagues at the office. And it also does the task of monitoring the environment in the office using its sensor suite. So let's talk about hardware. This is a very important part of our robot, given that we have a lot of software that needs to run on something really strong. So first, we're going to talk about sensors. So our sensor suite has CO2 sensors, air quality, ambient light, and temperature, which are monitored in real time. And we're using inter-RealSense technology for 3D vision to allow the robot to learn its environment, to do SLAM, and furthermore to understand facial expressions of people nearby, recognize them, and allow them to perform tasks according to their security clearance. Now, IoT boards. This is a very important part of the robot. First, for the sensors, we are using an Arduino 101, which is a faster and more featureful version of Arduino. It has built-in Bluetooth and a 6-axis IMU. And I think the most important part of our robot is the Intel Joule. Intel Joule runs ROS, and it uses the Intel RealSense R200 camera to do navigation. This is all done in a chip of this size. Now, we do need more processing in our case, so we are also using an Intel Compute Stick to run the virtual assistant, and we are using an Intel NUC Skull Canyon as a workstation for us for training or learning locations faster. For security, we have an Intel IoT Gateway NUC, which allows safe communication between the robot and the cloud. Now, I would like to hear your questions. This is the talk, and I do have some cool things to show you if you're interested. I'm gonna switch back to the camera. So I'm gonna see questions now. So what are the use cases of Astro? Okay, maybe you can see Astro is right back there, or at least one prototype of Astro. The use cases for Astro are to be a co-worker or an office mate that is not meant to replace people, but just to be a complement for things that can be quickly or easily automized and let's say done by no, not demo time. No, there will be a demo time really well not demo time. We will have an article published on Intel Developer Zone in the next 2 weeks, which will describe Astro. Sorry, I'm trying to read also the questions. What is the total cost of production of Astro? Well, that depends. I think the costs are, let's say, ballparking it around $2,000. That's using the ROS Turtlebot 2 base, which is quite expensive. But the hardware that we're using for it, it's really fast, so there's no compromise in terms of performance. How to build the Astro? Oh, you mean the hardware? Well, I don't have the Nuke. Sorry, I don't have the Joule right now. I do have an Arduino 101 over here. I do have an Intel Skylake Nuke for very fast processing, and I do have the compute stick, which is quite small, and this can run the virtual assistant. So these are the hardware parts. Okay, so the question. Sorry, I meant, do you have a website that shows how one can build their own Astro step by step? An article about Astro will be published on Intel's Developer Zone website, which will provide a lot of details on basically how you can build it yourself, yes. At least from a hardware perspective and entry-level software perspective. Do you plan to use recent NVIDIA GPUs to improve the inference time? Well, that depends. For the moment, we're using Intel Joule, which is an maker board this small. So I don't think it's compatible with NVIDIA GPUs, but we'll have to check. So how secure is Intel IoT's hardware? Well, we have the IoT gateway here. So we're using it to, let's say, filter and secure the data that goes to the cloud. So I would say it's very secure, but it does involve a bit more hardware. So what sort of computing happens on Astro versus in the cloud? For instance, Echo doesn't have a logic on the device. Okay, so we have a lot of logic on the device. That's why we need the really, really good hardware, because we are understanding language on the device. We are doing natural language understanding. I mean, after you converted speech to text, we are doing both locally and on the cloud. We're doing the intent understanding, and we are also doing both locally and on the cloud the fulfillment. So depending on, let's say, the hardware configuration, people can choose how much of the computation is done locally and how much can be sent to the cloud. But imagine that if you don't want to have your robot sending, let's say, critical information outside, then you would like everything to be able to be processed locally. So then you need more computing power. Yes, the data that we save on the cloud is secure. So we're trying to only save the important information there, or store information that is not by any chance gonna expose someone, or let's say saving their faces. We're just saving the trained data of their face. So it's not like personal information. So do you face battery life problems during operations when you use high processing? Well, yes and no. We kind of upgraded the battery of our Turtlebot, so it kind of goes up to like 3-4 hours. The Intel Joule is not really power hungry. It's actually super power efficient. So it's not, battery life is not really a problem. Okay. Have you considered the option to upload processing off-board completely rather than on-board processing? Well, we actually don't have to. Why? Because we do need a powerful computing unit, or a capable one, for doing SLAM and for being able to navigate its environment. So if we already have the good processing solution, we can actually afford to do much of the processing on the board. We could, for a fact, make the virtual assistant less fast, so that could cut down some costs, but it would kind of be against the point of having like a really virtual presence in the room. Okay, will company allow that? Have you used this in a real scenario? We are going to implement it in a few businesses to see how it works, and we're gonna try to see how people react to it. And I'm hoping that the data concerns are not really a problem, because we're not actually storing any I don't know, data that is critical. So if you're interested in building your own robot, please follow us on Twitter or Facebook at heliosvision.com, and you will probably see very soon, sometime in the next week or so, our article on Intel Developer Zone about building Astro, and a lot of hardware features and software alike. What platform would you suggest to go for onboard processing? Watson, Alexa, or Microsoft Cognitive Services? Well, it depends on your budget. We have the Joule, which can do pretty much everything, but I think you can use some cheaper alternatives depending on what you want to do with your solution. So thanks for attending, and if there's no more questions, I'll invite you to review the article in the next couple of weeks. Thank you so much.